You are given the state table below and the state assignment D equals 0, 1, E equals 1, 0, F equals 1, 1. Construct the state assigned table assuming D flip-flops where the state assigned table will have the following headings. This is easy. Again, you will want to have this. Okay, so our left-hand column is our present state, and we're using lowercase y's, y2, y1. Our middle is the next state, and the next state depends on the input. So we'll have the input w equals 0 and w equals 1. And our next state, we're using the capital letters, capital Y2, capital Y1. These are going to be 2-bit binary numbers, and then the last column is output Z. So in the table that you're given, you have letters D, E, F, and they tell you to use 0, 1, and you'll see in a minute why I'm putting 0, 1 there. 0, 1 for E, for D, 1, 0 for E, and 1, 1 for F. Now, we want to put in something for every possible 2-bit number. So if it's a 2-bit number, how many possible 2-bit numbers are there? 4. So what am I missing? 0, 0. And so that means these are don't cares. That's the only tricky part of this, because the rest of this is just matching. So D is 0, 1. So wherever we see D in this table, we put 0, 1 in this table. E is 1, 0. And F is 1, 1, and our output stays the same. If he does not tell you what to assign, you get to choose whatever you want. So if he didn't say D equals 0, 1 equals 1, you can make them however you wanted to make them. D could be 0, 0, however. Okay, so now comes the slightly tricky part, and it involves remembering stuff from 2741. We have to derive minimum Boolean expressions for the next state to be input to the flip-flops and for the output. So we have to come up with expressions for Y2, Y1, and Z. Okay, so I'll start with Y2. So we're going to do Y2. And my inputs are Y2, Y1, and Z. And I'll do a Carnot map. It should be W. Yes, thank you. And I know that wherever y2, y1 is 0, 0, I have a don't care. So I went ahead and put those in. Okay, now I just have to be careful and realize that y2 is the first column of these numbers. So it's really that I have 0, 0, 0, 1, 1, 0, 1, 1. And I just am looking at 0, 0, 1, 1, 1, 0, and this is W equals 0 and W equals 1. Because I'm just looking at the first column of numbers because that's Y2. And not the 0, 0, that was don't care. Okay, so at 0, 1, Y2, so I'm going to start with W equaling 0, which is this bit right here. So when W equals 0, Y2, Y1 is 0, 1, then Y2 is 0. When Y2, Y1 is 1, 1, and W is 0, then Y2 is 1. When Y2, Y1 is 1, 0, and W is 0, Y2 is 0. Now I'll look when W is 1, and that's the first column over here. So at 0, 1, I get 1. At 1, 1, I get 0. And at 1, 0, I get 1. And this gets me, I get that grouping, I get that grouping, and I get this guy all by itself. And so the bottom left has Y2 equal to 0, so that's Y2 bar and W bar, plus the wraparound has Y1 equal to 0 and W equal to 0, so that's Y1 bar, W bar. And the one all by itself has Y1, Y2, W bar. Okay, now we'll do Y1. And again, if Y1, Y2 is 0, 0, I have don't cares. So I'm looking at Y1, that'll be, and W equals 0. So W equals 0 is the first row of my Carnot map, and Y1 is the second row here, and those are all ones. Y1 here is 0 for 0, 1, and 1's in the other two places. So this gets us this group of 4 and this group of 4. So the square has Y2. and this one going across has W. Or is it W bar? W bar. Yes.
For the first part of that, shouldn't it be Y2 bar W, not W1?
Y, it should be, yes. Y2 bar W, thank you. That would be,
I'll probably put Y1 bar.
yes, and both of these. Yeah, it's W, yes. Both of those should be W, not W bar. Okay, lastly, we'll do Z. Z is easier. Because Z only depends on the state. So if it's 0, 0, we have don't care. If it's 0, 1, we have 1. If it's 1, 0, we have 0. And if it's 1, 1, we have 1. And so Z equals Y1. Questions?